on YouTube where we are doing a session on number systems for CAT, specifically for CAT 2019. And we will be doing two parts to this today. The session will be, I'll be talking not two parts, but actually I'll be talking on two dimensions in the session today. The first dimension would be based on or would be focused on your ability to solve questions and looking at a few questions of the exam of the last couple of years or so. And then the other dimension of what we'll be talking about will also be on how to approach these questions and what to do inside the D-Day, what kind of shortcuts, techniques, methods you need to do inside D-Day if you want to actually improve your chances of doing well in this exam on 24th November. So, let me just open my notebook window for you. Uh, so the first question I'm picking up for you today is question number 99. Let me just organize the desktop so that you can see both the question as well as the whiteboard together. So question number 99 is the first one, and it's a question on uh, it's a question on number systems. So I want you to first try this question and think about this before I come up with the solutions for this. So it's both a session on facing number systems as well as on strategy for CAT, as well as solving questions on the CAT. So this is the first question which I want to talk about today. The question says let A1, A2, A3, A4, A3n be a geometric progression, arithmetic progression with A1 3 and A2 7, right? Yeah, so it's now showing me that I'm live. So now the first thing in number systems, in fact, it's true not just for number systems but any part of your CAT quants section. And the first thing that you need to take care of when you're solving the paper is to make sure that you have a structured read and react situation, or a structured read and react uh, structured read and react framework which you operate through the exam. So what will happen in every question, uh, you're going to have points inside the question at which you should stop your reading and you should move into thinking about what that is said. Now this is at cross purposes to what your school teachers have told you. Your school teachers have told you that read the question once, and then second reading you start solving it. Right? Now inside the CAT, you don't have this luxury of the second reading by itself, because the CAT exam in 60 minutes you're supposed to solve 34 questions in quants, and if you are reading only once, you'll barely reach the 34th question if you have been efficient while doing your solving. So you'll be able to see all the questions. But if you go for a second reading, then it is physically impossible for someone to read more than 20 questions in the paper. And obviously, if there are two students X and Y who are equally skilled at solving maths, and X reads once and Y reads twice, X will have a choice between 34 questions. Y's choice will be between 20 questions, 22 questions. If the solving skills are equal, there is no way Y will beat X. Because if both of them can solve around 70% of the questions they see, Y will solve 14 to 16 questions, X will solve 22 to 24 questions. And that is where the gap between the great guys and the good guys happens inside the CAT. So this is one component of strategy also to be used for the number system questions. That whenever you have number system or block 1, actually this is what I'm taking this for. Whenever you have a point where you have to sit and analyze, stop and analyze the situation, you should do that. So in this question right now, the highlighted part that I have, this is a point at which there's enough information to sit, to stop reading and start analyzing things. So the question says, let A1, A2, A3 and be an arithmetic progression with A1 3 and A2 7. So there are two things to notice here. The first thing to notice here, before you move ahead in the question, the first thing to notice here is that the number of terms in the arithmetic progression is a multiple of 3, because 3n means a number which is multiple of 3. So number of terms in this arithmetic progression is a multiple of 3. So you can't, for example, you can't stop this arithmetic progression at A5. You can't have this AP as A1, A2, A3, A4, A5. It will have to go to A6 or A9 or A12. It can go to A30 with n is 10. But it cannot stop at A5. It cannot stop at A7. Right? It will always stop on a number which is a multiple of 3. This is one thing you notice here. Right? And the second thing you notice here is that the AP with the first term 3, second term 7, third term 11, fourth term 15, this is the AP. So you have the AP, but as I said, you can't stop it at this point. A stopping point for this, a possible stopping point for this can be 23. It can be 23. And for 23, the value of n, because you're going to A6, the value of n will be 2 here. Right? So that's something you have to understand here. And then the question says, the question moves on. A1 to A3n, the value of sum of A1 to A3n, this is the next trigger in the question. The value of the sum A1 to A3n is 1830. Right? So now this is again a reaction point. We are not going to go ahead from here. You should not go ahead from here, from this point. So A1 to A3n is 1830. That means we are looking at the sum of this series to become 1830. Now from this point, there are two ways in which you can move on. One way is the standard AP formula, n by 2, wherein this n is not the same as this n. Right? The value of this n will essentially be 1/3 of the 3 times the value of this n. So this is our normal number of terms n situation. N by 2 into 2a, 2 into 3, plus n minus 1 into d. This should be 1830. This is one way to react to this situation. So 6n plus 4n if I take the 2 on the other side, 6n plus 4n minus 4, is equal to 3660 kind of thinking here. I hope I've got everything right here. N by 2 into 2a plus n minus 1 into d. That's the formula. So if you solve this, you can get a value for n from here. But that value for n here in this form would be slightly difficult to do and will unnecessarily take you many steps. Instead of that, what you could do is you can do a small trial and error. So you know that a3n for the series needs to end at a multiple of 3. So if I think of, let's say, a30, because I have to total 1830 there. So if I think of a30, then the last term of this series will be 29d plus 3, which is 119. And if you look at the sum of this series, the average of the first and last term is 61. And since there are 30 terms in the series, 61 into 30 does give me 1830. So that means we are taking this series till 30 terms. We are taking this till 30 terms, till 119. That's the reaction to this point. Now, you might wonder, how did I get the 30 there? Or how will we think of 30 directly? Right? So that thinking of 30 directly there at this point was not completely random. There was definitely a trial error angle to this. But there were a couple of things that I could see here in this series when I'm trying to think of this logically. I realize that a series like this, no matter how many terms I take, the average of the series will always be an integer. The average of the series will always be an integer, because if I go for 2 terms, the average is 5. If I go for 3 terms, the average is 11. If I go for 4 terms, the average is 9. So whatever I do, this series till 3n, whatever 3n you are taking, the average of this is always going to be an integer. And the sum of an AP is always given by number of terms of the AP into average. Now, since the sum is in the first part, in this highlighted part on the right, the sum is given as 1830, and the average has to be an integer, and n anyway cannot be a non-integer. So basically, this is a factor pair of 1830 that you look for. And then if you start thinking about what factors, so if you try to go for and the other factor, of course, is that if I go only till a6, for example, if I go only for a6 and I take a sum at this point, this sum is going to be too small. Approximately what exactly average is 13 and 6 terms, so 13 into 6, 78. But even if you think approximately average will be 10 and 6 terms, you're in the range of 60, 70. There is no way you're going to get an 1830 on this at this point. So you know that you have to go a little bit ahead to get to 1830. To 20 terms, 18 terms, if you go for, you still realize that the average is too small. If you go for 18 terms, let's say 3n is 18, then you need an average of 100 plus. एक तो इंटीजर भी नहीं आएगा, but it's not going to be in that range, because 18 terms तक इस series का value will barely be 70. And these are the situations where your numerical thinking, your numerical logic has to be strong, so that you can work these out. So taking that 30 was not an accident from my side. It was a guided, instinctive number that was taken there. And once I know it's integer into integer, and I'm thinking of 3n in the right range, 24, 27, 30, the first number that flashes with you will be 30, because you can see that it divides 1830. So if you can see that 30 divides 1830 there, then this problem becomes much easier. It's much easier than going through the n by 2 into 2a plus n minus 1 into d, because this is the mathematical trigger for this highlighted part of the problem, right? Of course, maybe you can just replace this with a 3n to understand that you're using 3n there. But still, as I said, this is going to be quite tedious compared to doing this is going to be much more tedious the arithmetic way. First of all, the amount of writing you have to do in this to get to the answer, and the problem of opening something wrong, of not multiplying the right things, of missing out the two and taking not taking on the right. Those kind of silly errors are much more likely through this process, because you have to guard your thinking across 5 6 steps to get to that answer. But in this process, I'm thinking straight. I know it's 30 terms. So once I know that A3n is 30, is A30, that means n is 3, sorry, n is 10, then I'm looking for what is the smallest positive integer m, such that m into, now this is the next trigger in the problem. This is the next trigger in the problem. M into a1 plus a2 plus an is greater than 1830. This is the next trigger in the problem. We want m into a1 plus a2 plus an greater than 1830. And now this is very simple, because we know a3n was a30. So an, this an is a10. So we're looking at the series 3, 7, 11, and for a10 you'll have to add 90, so 39. You're looking at this series, m into this should be greater than 1830, right? And this series has a sum of 21, average of the first and last numbers, into 10, 210 into m. 210 into m should be greater than 1830. So the answer is very clearly that m should be greater than 9. M should be 9. Smallest integer for m is 9. Because 9 suffices. 8 does not suffice. 9 suffices to make this greater than 1830. So if you look at the structure of thinking in this question, you'd realize that this is completely hands-free almost. It's just your ability to handle numericals, which is going to be an important component of your CAT prep, of your CAT D-Day strategy. That you should be able to look through. Your logic has to be. I always talk about it this way, that your logic has to be supported by the numericals behind it. Your logic has to be supported by the numericals in your mind, so that if you want to test some logic, your numbers should support you. It should not be that, okay, now I have to do this long calculation and this is not natural for me, it's going to be difficult for me to do this. So that's essentially the important thought process behind this. So the next question for you is this one, the 100th one. If the product of three consecutive positive integers 15,600, then the sum of the squares of these integers is. So three consecutive positive integers, product is 15,600. Now again, our maths has taught us stuff like n into n plus 1 into n plus 2 is equal to 15,600. And as you know, as you can see, if you try to go into solving this, you're going to get stuck in a pretty difficult to understand or difficult to use algebraic expression. So you can try to think of this. You can try to think of this in terms of what to do. But as you can see, this is going to be difficult to actually work this out. N cube n square. I mean, this is going to end up into n cube into n cubes, n squares, and n's and constant terms. And solving it is going to be a task. So, what do you do in this question? Do you have a numerical approach? So, the numerical approach in this question is that you think of what numbers, what possible values. So, if I for example, two couple of things come to mind here before I think of. Okay, let's before I go into some things that come to mind when I look at this. When I look at this, some things that come to mind when I look at this in terms of number system logic. Before that, let's do a blind trial and error. Okay, if I take n as 30, 30, 31 into 32, I can clearly see that 30 cube itself is 27,000. So this is going to be much larger than the required 15,600, so 15,600. This is going to be much larger. Instead of this, if I go to 20, 21, 22, you can see that this is below 10,000. So our answer is going to be somewhere in the range of above 20, n above 20, and n below 30, right? Now to that understanding, if you apply number system logic to this algebraic situation, so rather than now see, again, strategy wise, you have a numerical approach to solving number systems questions. So if I went ahead with trial and error of 21, 22, 23, 22, 23, 24, etc., I would ultimately get the value of which number n is, and then accordingly find the second part of this is asking me the sum of the squares of these integers. I would be able to do that, right? So that is just a numerical solution, right? Solving this with going into a cubic equation is an algebraic solution where I'm getting into complete algebra while solving it. But what the most critical solution is algebra plus numerical, one step algebra, little bit of algebraic logic and numerical logic together. This is the most potent combination of thoughts, and this is not just for your number systems, it's for the entire quants area. This is your most potent structure of thoughts that you should use. So you will appreciate that if I straight away go into a numerical trial and error, getting to the value will still take me some time. It'll be a task. But there, if I apply numerical logic to the algebraic situation that I'm facing, if I apply numerical logic to the algebraic situation that I'm facing, what will happen is that I'll get to see that my right hand side ends in two zeros. And two zeros can only happen if there are two fives and two twos in the number. And because n into n minus 1 into n plus 1 into n plus 2 can have at best only one number with a multiple of 5, that number will have to be 25 given the range we are looking at. So 25 is one of the numbers. So I'm in the point where I've got 25 into 26 into 27, 24 into 25 into 26, or 23 into 24 into 25. I have three possibilities now only, because unless I put a 25 in the mix, I'm not going to get a number ending with two zeros here. And then the next part becomes the calculation of which of these will work. So for that, rather than trying to multiply and get this, the best way is to keep these two zeros aside. And to keep these two zeros aside, you'll have to take out, for example, suppose I try to do this here. To get two zeros aside in the answer, I have to take out the 25. And I need two twos, but there's no two twos. 26 has only one two. So this number is not ending in two zeros definitely. So this is not going to be the answer. Right? these two both have two twos because 24 has a couple of twos. In fact, it has three twos, and here 24 and 26 both give me twos. So if I want to look at which one of these is giving me the answer, once I remove a 25, I'll need to remove two twos from here. So if I remove two twos from here, from 24, I'm left with 6. By remove, I'm not talking about subtraction, I'm talking about the factor removal. So 24, from 24, if you remove a 2, it becomes 12. You remove another 2, it becomes 6. So if I make this a 6 and I take out the 25 and get the two twos away, I know I've got 100 in my calculation. And now this has to be multiplied by 156 to get 15600. So is 26 into 6 156? The answer is yes, and hence 24, 25, 26 is the numbers. Just see what happens when you go with a wrong value. Just see what happens when you go with a wrong value. If you go with 23, 24, 25 for instance, to take out 00, you'll take away the 25 and you'll leave a 6 here. And 23 6 are 138, not 156, and hence this can't be the answer. So as simple as that, right? So that's what I talk about. So if you look at the situation you are in the algebraic case here, n into n plus 1 into n plus 2 kind of situation. If you see this situation and you went algebra, you went completely algebraic on this, you would realize that this will be a very, very tedious question. The amount of writing and the amount of concentration you need, the amount of steps you need to be able to carry through the question to the end is going to be humongous and unachievable in the CAT under pressure. If you go numerical only, 20, you know that the number is above 20, 21, 22 and below 30, 31, 32. Your numerical skills have to be really strong. I'm not saying that you should not make them strong, but your numerical skills will come to the fore of how quickly you can reach 24, 25, 26 for this. Because you're not doing any further mathematical analysis. Any further logical mathematical analysis you're not doing in this question. You're just saying, okay, I'll just find these numbers. So in this case, you'll reach it, but you are some trial and error away. But in the last case, where you started applying logic and you started reading this equation and started applying logic to this equation, you had a completely different outcome because you had a situation where you had everything in control and the calculations become easy. It was almost talking to you about what to do. So please remember, before I wind up for the session, please remember a few things from my side. First of all, critical part, you have to make sure that you have to read questions only once, not twice, and reading has to be done on this pattern that I showed you. This will be your biggest takeaway from this session. You reach a trigger point, understand what it means, react to it, do the complete reaction, then move to the next part of the question. One. Second, more importantly, as I said, don't go only with algebraic solutions. You have to have the algebra knowledge, but algebra, going through algebra throughout the question inside the exam might be hitting your head against a brick wall. So anyway, coming back to this question, once I know 24, 25, 26, the rest part is just a formality because the question is asking me the sum of the squares of these integers. I know the integers. So the sum of the squares is 576 plus 625 plus 676. So that's 600, 600, 500, that's 1700, 76, 101 and 177. So 1877 is the answer, and you have clear vision of what you need to mark here. Right? Any questions, anybody, before I wind up then? So if there are no questions, then I will okay, one last thing which I would like to let you know. I'm on Academy Plus also, Parth, and if you want to join Unacademy Plus, please use my promo code Arun M Sharma. We'll give you a 10% discount on the existing fees. Arun M. Sharma is the promo code. You can use that. It'll give you a 10% discount on the existing fees that you're already getting on Unacademy Plus. My CAT 2020 courses on Academy Plus, I teach LRDI, and I also teach practice questions, practice sessions on quants as well as verbal. So our courses on LRDI etc. will start sometime in December. We are starting some session in December, and also a joint course with me and Meenakshi Upadhyay ma'am on where I'll be doing it's a practice and strategy course for CAT 20. We're starting in January on fifth on first week of January actually, where I'm doing strategy for quants, strategy for DI, strategy for LR. And actually, ma'am is doing strategy for verbal, and then we are going to get you through practice questions on each of the areas of quants and verbal. And parallelly, my LRDI course will be separately available on that. So I look forward to seeing you part on that, and I look forward to seeing other people. Please use this promo code for Unacademy Plus. Arun M. Sharma. That's you know my name. There's an M in between, right? So thanks a lot, and hope to see you, Path, in the sessions. Bye bye now. See you.